So software development methodologies, yeah. I would ask you, have you studied the software engineering before?
Yeah, I've studied. I've done that before. Yeah.
Okay, that's good. Yeah,
Methodology.
because the software engineering at the normal level is somehow a kind of introduction to the software engineering, and in that particular unit that's being taught at the level 4. Normally, you learn like a software engineering principle, traditional software development approaches, and then you talk about analysis, design, and implementation, and somehow a basic level things. Yeah.
Yeah.
So this advanced level, especially on the software development methodologies, is regarding the unit content. Yeah, it's a little bit mixed up if you would have a look at the content, but what we will do, we will be following the the lecture I have prepared, and that would cover the majorly the software development methodologies, and the learning outcome too would be based on the effectiveness of the particular software engineering methodologies. But instead of explaining the effectiveness or evaluating that particular methodologies are separate in the second learning outcome, I will be going through into the first lecture. Did you get it?
Yeah.
So the there would be about more than 60 slides in total for this unit. Yeah. So about 25 we will cover today, and rest of them we will cover in the next class. So by explaining all of the system development methodologies, these two learning outcomes would be covered. Yeah.
Okay.
So simply, software development is the process of developing software through successive phases in an orderly way. This process includes not only the actual writing of the code, but also the preparation of requirements and objectives, the design of what is to be coded, and confirmation that what is developed that has met the objectives. So development process through some steps, and to be carried out in a sequential way in order to make sure that the requirements are being fulfilled, and whatever you are going to deliver, that objectives are fulfilled. Yeah. Now this development should have been gone through the system development life cycle. So the system development life cycle, also referred to as the application development life cycle, that's a term used in the system engineering, information systems, and software engineering to describe a process for planning, creating, testing, and deploying an information system. So any information system, you create a project, there is some purpose, you create a project, you have a database at the back end, you start with plan, then you create, test it, and deploy it. System development life cycle is a project management model that defines the stages involved in bringing a project from inception to completion. So what is SDLC? That are basically the stages, yeah, that you use in a sequence. So obviously it's a framework that describes the activities performed at each stage of a software development project. Is that clear? These are the simple definitions, that we explain about it. Yeah?
Yes.
Now, what happens in the system development life cycle? You start with planning and feasibility study, then you do the system analysis and requirement definition, then system design, implementation, integration, acceptance, installation, and deployment. So are you clear about the feasibility?
Yeah.
example, yeah. For example, if you have a plan to make a project, then you need to look at that whether it is feasible to go ahead with or not. For example, if you have an idea to create a website to sell something, yeah, for example, to sell the mobile covers, yeah, then you need to look at that whether if this website would be developed, it would cost you and like it to make it a commercial website and whatever you would be selling, and after the launching the website, do you think you would get number of clients as compared to the eBay and you would make a good business, or no? Maybe for small mobile cases, yeah, or covers, eBay is the only thing that is unbeatable. Makes sense?
Yeah.
Yeah. So somehow you need to know the feasibility of the project. So in simple terms, planning and feasibility is established. It describes the desired features and operations in detail, including screen layouts, business rules, process diagrams, pseudocode, and other documentation. So normally there's a term, system analysis and design is basically in the analysis, you know the requirement, and in the design, you create a kind of diagrams, yeah, a layouts, a rules, a process diagrams, a kind of pseudocode. Pseudocode is, that not a computer program, but a kind of human language, some messages and any documentation, like, the uh, architecture of building, the architecture diagram of the building you create. Okay, this will be the layout. In the same way, the system design is created for, a kind of what should I say, a kind of skeleton, yeah, a skeleton of the program, and the structure of the program or the system. Is it clear?
Yeah.
Okay. And then in the implementation, the real code is written here. Integration and testing brings all the pieces together into a special testing environment, then checks for errors, bugs, and interoperability, acceptance, installation, and deployment, final stage of initial development, where the software is put into production and runs actual business. And then obviously maintenance, what happens during the rest of the software life, for example, any changes, correction, additions, moves to a different computing platform. This, the least glamorous and perhaps the most important step of all, goes seemingly forever. So maintenance is always, open. The needs can be open always, and changes or correction additions would be long lasting, and you can't expect that this is final. Maybe certain features that you didn't use, for a couple of hours, a couple of years, yeah, and they suddenly arise, yeah, that okay, there was any problem, yeah, that needs to be done. I would start with certain system development methods or software development methods. So obviously the software development methods or system development methods, I explained in this slide that they are related with the systems and software development, engineering, or information system. So this term is interchangeable. So we start with some of the methods like a waterfall, V-shaped, prototyping model, incremental model, spiral model. Until here, these are certain approaches, and then agile development is kind of advanced approach that is comprising of development, software development methods, rapid application development, Scrum, extreme programming, rational unified process. So hopefully we will try to cover these 5 of them today, and in the next session we will discuss the agile process. Yeah. Now, do you know something about the waterfall model?
Yeah.
Can you explain to me?
The waterfall model is the software development method where the process starts from up to down.
Okay.
Waterfall, like a waterfall shape.
Yeah.
Waterfall up to down. And so the levels are from up coming down to the bottom.
Yeah. As their name says, and what is that is actually?
It starts from I think from the basic.
Yeah.
From the requirements in just the opposite of what is it called? What's the other model name?
I mean, what does the waterfall look like, and what is the way, or how does it work? I like.
Okay, it follows the requirement stage, the designing, the implementation, test, installation, and maintenance in that order.
Yeah, but others are also in that order. What is the difference? What does exactly waterfall says?
I am not sure if I get the question exactly how it means.
Yeah, maybe. I mean, since you said that it has these, it is called waterfall model. It goes into the waterfall model, and it has steps, blah blah blah. But let me tell you the actual name and its interpretation. What happens if you obviously you have to go through these requirement, design, implementation, testing, installation, maintenance, and you cannot do the installation before the requirements. Can you do?
No. It has to follow. It has follow the sequence.
No, but obviously in other models there is also the sequence. Then what is special in the waterfall model then?
Because the waterfall, the water does not go back up.
Okay, then how about in this model? How do you say that these things can't go back?
How do you set it to go back?
I mean, how do you define the water into the project, into the software model? Okay, let me try to explain. Yeah.
Okay.
Waterfall, like if you are in the requirements phase, yeah, once you are there, you complete it, yeah, When you move to the next model, you cannot go back.
Yeah.
Yeah. You are not allowed to reconsider or change the requirements. If you are in the design phase, you cannot go to the, you know, I mean, you cannot go to the requirements, and after design, if you are implementing it, then you cannot go back to the design or change the design. Yeah, it's like a water. Once the water is fallen, then it cannot go up. Yeah, so
that's what I said before.
yeah,
Maybe.
but in exact wording, that each phase has to be completed once and cannot be, done again.
Okay.
Yeah. That's the proper wording I wanted you to explain. Yeah.
Okay.
Yeah. So any phase has to go through in a sequence, and no iteration would get a turn to be repeated. Right?
Yeah.
Okay, so requirements, the definition about the requirements are simple. I mean, I don't need to explain the requirements, design and implementation, again. Do I need to?
No.
Okay, so we can skip the definitions from the slide. So strengths of the waterfall model: easy to understand, easy to use, there is no any complexity, provides structure to inexperienced staff. You give the number of sequence to the inexperienced staff, even they will follow it. Yeah. Milestones are well understood. What are the milestones?
The steps.
No.
The milestones?
Yeah, that is the term used in the software engineering. So milestones are the deliverables. Whatever you have to deliver, that is well understood. Okay. And sets requirements stability. The requirements in the waterfall model are stable. They are not allowed to be changed. Good for management control. You have a plan, you have a staff, you have a track. You put everything into the track, and you are done. Works well when quality is more important than the cost or schedule. Yeah, you don't need to rush. You need to work in the steps. Whatever you have the stage, you do it well, and then you produce the quality, and you will not be asked to do any rush or schedule change in the schedule. Yeah, so that's the strength. The weakness of this model is that all requirements must be known upfront. What happens that most of the time you try your best to get the requirements fully, but unfortunately you don't get the full requirements in the one go. Is that true?
Exactly.
Yeah. So that is the disadvantage, that your requirement must be known upfront. Deliverables created for each phase are considered frozen. Yeah. So once each phase is given to you, it means it is frozen. You can't do anything to it. Yeah. Can give a false impression of the progress. Like, probably you might see that a particular phase was started, and that was stuck over there, but that's not true. Maybe it takes longer to reach on particular implementation phase, but it will give you a false impression. However, whenever each phase is to be done, then obviously if it won't pass on to the next phase until the particular phase is completed. Make sense?
Yeah.
Integration is one big bang at the end. So obviously once you have everything, and then it will create a burden, yeah, at the end. Instead of, if it was a kind of incremental development, then it would have been integrated from time to time. However, in this model, the integration is a little problem at the end. The all would be it can be an overhead. Yeah. Little opportunity for customer to preview the system until it may be too late. Yeah. So like the customer gave you the requirements, and then you created the system analysis, then did the design, implemented and tested and provided. Probably it would be very late for the customer to show them. However, if it was a kind of, if you were allowed to produce the prototype on the smaller requirements, then they could see the system. However, this is a disadvantage, that the customers won't be able to see the project. Is that true?
Yeah, it's true.
When to use this waterfall model? When requirements are very well known, product definition is stable, it's non-changeable. I mean, it is not changing that much frequently, and technology is understood. You select the technology, whatsoever you want to do, you should not have any problems of the technology as well. So that's about the waterfall model. Then have you heard about the next is a V-shaped system development lifecycle model?
Yeah, I have.
Yeah. Can you tell me what it is?
I think it's the opposite of, more or less opposite of the waterfall.
Basically, it's not the opposite. It is a kind of variant of waterfall model that emphasizes the verification and validation of the product at each stage. So it's same way it goes through the waterfall model. Yeah. But at every stage you verify and validate. Yeah. In the verification, you check you are doing the product right and you are doing the right product. Verification and validation is explained in a term that you are producing the right way, yeah, and finally you are doing the right product. Okay. So if you started the requirements, then the verification and validation should be done at the same time. For example, you are at the detailed design, then you should carry out the unit testing. Architectural level design, you should carry out the integration and testing. Like product requirements, basically it is a little bit difficult to explain the V-shaped model at every stage. However, you can replace the word of verification and validation at each stage in simple. Yeah?
Yeah.
So you carry out, in parallel. Now let us see the steps. So steps for verification and validation, like a V-shaped model, they are obviously the same that we have been carrying out in all the system development life cycle, like requirements, the specification analysis, architecture, diagram, detail diagram, production, operation, maintenance, acceptance. So do I need to go through these again?
No, these ones are, I think, self-explanatory.
Yeah, and we base on these all, definitions for every model. Strengths. Emphasize planning for verification and validation of the product in early stages of product development. Yeah, so make sure that since the implementation and design starts, yeah, then you need to verify and validate. What you need to do, you need to see that are you doing it in the right way and you are doing the right product. Yeah, so that's about the definition of the verification and validation. Each deliverable must be testable. Okay, so for example, you are in the you created two diagrams. then you must test those diagrams, in parallel. Yeah. So project management can track progress by milestones. So milestone is basically the deliverable. You created 3 diagrams, you tested it. Yeah. You tracked it. Yeah. And then in the implementation, you created 2 diagrams implemented, then you tracked it, and it helps you to get verified and validated. And it's not that much difficult, it's easy to use. For example, you are going through the waterfall model, you are creating and as well as verifying and validating that you are doing the right thing in the right way. That's the strength. Yeah. Now let us look at the weakness. Does not easily handle the concurrent events. Yeah. So obviously, whenever you will be verifying any of the phases, yeah, then it would basically make you complicated. Yeah, that every time you are checking it, and every time you are validating it. For example, if you are coding, yeah, and somebody from the verification and validation team is disturbing you again and again, would it be pleasant for you?
Not at all. No.
So you would be annoyed. You would be saying, "Yo, let me finish it first, and then let me do." But somebody, your supervisor, would be on your head, and he would be asking, "Oh, let me see first how you are doing," and then so it's not easy to do the things in concurrent events. Yeah, does not handle iterations or phases. So if you are going into the iterations, you are going step by step. So it will not allow you to do the iterations because there would be some interruption into the phases. Yeah.
Yeah.
Does not easily handle dynamic changes in the requirements. So for example, if you verified it and approve it, and certain changes came into the requirements, then dynamically you won't be able to verify and validate it. Again, it will make it complex for you. Does not contain risk analysis activities. So obviously that's also the weakness of this model. Yeah. When to use the V-shape? Excellent choice for system requiring high reliability, hospital patient control application. So wherever you want the high reliable software, you use the V-shape. All requirements are known upfront, solution and technology are known. So that's the criteria you use for the V-shape. Yeah.
Yeah.
So basically these models are being taught at certain level of theoretical grounds, but when you really need to try this model, then you need to start your research, isn't it? Yeah. Then probably certain case study you will select it, and then see the particular adopted the particular model, yeah, at particular time, and they got the benefit. Probably they didn't get the benefit, and something like that. Yeah. So that's the really important thing to consider. Yeah.
Yeah.
Okay. So next is the prototyping model. Structured evolutionary prototyping model. Do you know something about it?
I've not done this module before, or it's been a long time, so it's just coming back. Most of the things that I have heard all this prototyping.
I understand. Yeah. So prototyping is like you create small get little requirement and create a prototype, show to the customer. If he's happy, then add or change something, and keep on doing something. That's a prototyping model. So developers build a prototype during the requirement phase. Prototype is evaluated by end users.
Users give
corrective feedback. Developers further refine the prototype. When the user is satisfied, the prototype code is brought up to the standards needed for a final product. For example, if you are on, freelancer, yeah, somebody needs a website, then people, what they do, sometimes they said, okay, give me the requirement, I would, work on it, blah, blah, blah. And somebody, what they would do, quickly, they would create a demo, and they will make you happy and show you the demo. Okay, hello sir, I have worked on your, requirements. Look at this. This would look like this, and obviously, further implementation will be done according to your needs. And have a look. Should I carry out? Okay, yes, I'm happy at the moment. You complete the two sections. I give you full detail, and they gave you a further work done, and in this way. That's basically the prototyping. Yeah. Now the steps involved in the prototyping evolutionary method. A preliminary project plan is delivered, not a full but a preliminary, yeah, that starting plan you should have, and a partial high level paper model is created. Okay, then model is a source for partial requirement specification. A prototype is built with basic and critical attributes. The designer quickly builds the database, user interface, algorithm functions. Then the designer demonstrates the prototype. The user evaluates for problems and suggests improvements. This loop continues until the user is satisfied. Strength: customer can see the requirements as they are being gathered. Developers learn from customers. A more accurate end product. Unexpected requirements accommodated. Allows for flexible design and development. Steady, visible signs of progress produced. Interaction with prototypes stimulates awareness of additional needed functionality. As compared to waterfall model, the user is not given the output very quickly. However, the users are given very quick output of the progress, isn't it?
Yeah.
Okay. Weakness: tendency to abandon structured program development for code and fixed development. So what happens in the structured programming? You cannot jump into the different sections of the programs. So that's a weakness of the prototyping. Certain structured programmings, for you really need to create the structure of the program, and then you need to implement it. However, the easy programming like a Visual Basic, and where the buttons and few things are already created, and you drag and drop on the button. Have you heard about the Visual Basic?
Yeah, Visual Basic. Yeah.
You just put the buttons and show someone, okay, this is your project, and further the button will be implemented. Yeah. But the normal programming like a Java, and you really code, then you can't adapt these programs very quickly. Bad reputation for quick and dirty methods. Yeah. And basically that's a weakness. Yeah. You can get the bad reputation because you would be producing the quick and dirty methods. Yeah. But you have to achieve something. Overall maintainability may be overlooked. Yeah. The customer may want to prototype delivered. Process may continue forever. Yeah. Every time, oh, I didn't do this. You didn't tell me this. Okay, blah, 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 something would happen. Well, it's not our headache. That's the problem of the method. Whichever the method you would select, the consequences, the advantages and disadvantages, and based on this, you need to select that which one you want. Yeah. When to use: the prototyping requirements are unstable or have to be clarified. Develop user interfaces quickly. Short-lived demonstrations. New or original development in a project with the analysis and design portions of object-oriented development. So in object-oriented analysis and design, you sometimes need to create the prototypes as well. Yeah.
Yeah.
Now, incremental system development model. Incremental is basically you start the system feasibility, then get the requirements, produce the design, and then you implement the design into little increments. For example, there are 10 forms to be designed, like a 10 functionalities need to be implemented. Then what you need to do, like implement a portion of functionality 1, then implement a portion of functionality 2, implement a portion of functionality 3, implement a function of portion of functionality 4. Then obviously you implemented, then coded, integrated, and tested. So do it in increments. Yeah, do a little part on every part of the project and go through, and then you verify it. Is it clear?
Yeah.
Okay. So construct a partial implementation of a total system, then slowly add increased functionality. The incremental model prioritizes the requirements of the system and then implements into the groups. Each subsequent release of the system adds functions to the previous release until all design functionality has been implemented. Yeah. Strengths: develop high risk or major functionality functions first. Each release delivers an operational product. Customers can respond to each build. Uses divide and conquer breakdown of tasks. Lowers initial delivery cost. Initial product delivery is faster. Customer gets important functionality earlier. Risk of changing requirements is reduced because you are working at chunks. Yeah, and you would have not completed the whole part at all if somehow the changes were there. If you expected the changes, then it would be easier to do the changes into the subsequent increments. Is it true?
Yeah.
Okay. Weaknesses: requires goals, good planning and design, requires early definition of a complete and fully functional system to allow for the definition of increments. Well-defined modules in the module interfaces are required. Some will be developed long before others. Total cost of the complete system is not lower overall. So these are the weaknesses. When to use the incremental model: when risk, funding, schedule, program complexity are need for early realization of benefits. So if you think there is a risk in the program, the funding is a problem, schedule is a problem, then in order to realize the benefits, yeah, early benefits of creating the software into chunks, you select this. Most of the requirements are well known upfront but are expected to evolve over time. That's why you do not complete any one phase of the project at all, but you keep on working on the all phases of the project a little, so that if any changes evolve, then you shouldn't have any difficulty to change any particular phase entirely. Make sense?
Exactly.
Yeah. A need to get a basic functionality to the market early. So what would happen? Let's say there are 10 functionalities and probably you are working on them slowly, and then you can say probably this is a beta version. Yeah. So you can quickly launch a product with versions. On projects which have a lengthy development schedules, so large projects could be released by small increments. Yeah. On a project with a new technology, and new technologies are produced, they introduce the all of the functionalities, for example all of the features provided by the technologies, but they needs to be gradually changed and incremented and enhanced. Yeah.
Yeah.
The spiral model. Spiral is the basically the model where you do a kind of rapid application development like a prototype, but you add a risk analysis into every phase. What do? You identify the risk. For example, you started the you took an objective and took the constraints, the requirements, then you evaluate whether the requirements are fine. What you need to do, you identify the risk and produce a prototype. What happens? And then in the next phase, you take the requirements, you judge the or analyze the risk, that whether the implemented software is correct, is it on time, schedule, and then you move further. So this process continues in this way. Did you study this spiral model before?
Yeah.
Yeah. So that's the logic behind that. At every iteration you come to identify the risk. So each cycle involves the same sequence of steps as the waterfall process model is, but add some risk analysis at every stage. That's the logic behind this, spiral model. Yeah. So how? So the spiral quadrant, for example, determine objectives, alternatives, and constraints. You know the objectives, alternatives, and constraints. And then in the evaluate alternatives, identify and resolve risks. This includes the identification of alternatives, risks, and risk involvements. Yeah. And at the other quadrant, you develop. What you do, create, design, review, develop, inspect, and test the product. And then again in the phase, you develop a project plan, develop configuration management, develop an installation plan. And looking at this phase, again you fall into the identification of the risk. Yeah. So basically this is a cycle. Yeah. Okay. So
Yeah.
you need to go through this cycle, and let us see the strengths provides early indication of undefeatable risk without much cost. So if you will be doing the spiral, then you can identify those kind of risks which cannot be reduced. Yeah. And you need to be very serious about it. Maybe you can stop the project development. However, you would be saved from the big risks. Yeah. Users see the system early because of the rapid prototyping tools. So especially the spiral is a kind of waterfall model, and also it incorporates the prototyping, yeah, as well as the risk analysis. So critical high risk functions are developed first. So in addition to the more definitions of this spiral model, what happens, you every time check the risk, that which part of the project is more risky and you need to develop the first. Yeah. So at every iteration you check the risk. The design does not have to be perfect. Users can be closely tied to all life cycle steps. Early and frequent feedback from users can be given. Cumulative cost assessed frequently. So in this way you can assess the cost of the total project very frequently. Weakness, time spent for evaluating risk too large for small or low risk projects. So obviously in normal way, if you are given the project, then you have to complete it, and that is your aim. But in the spiral, you have to check every risk. For example, the pressure is on your head, and your boss is asking you to do not fail at any point. That's why you are under pressure. You need to check the risk of every module every time, so that it shouldn't fail. So that's a weakness, that you cannot trace every evaluation of risk for a small project or low budget uh, projects. That's why it has a weakness. But if it is a critical project and you don't have any problem of budget and timing, then you check on risk, and at least, because you have to work it, you have to produce error free, risk free software at any cost. You have the cost, you have to do it, you are not worried, then you use this model. But if it is a weakness, that's a weakness of this model, that for small projects or low cost projects, that's not good. Time spent on planning, resetting objectives, doing risk analysis and prototyping may be excessive. Model is complex. Risk assessment expertise is required. So you can't say that, I take the risk, this part is very difficult, it will, kill your time. You can't say until you have expert and they can explain to you that, oh, no, that particular part is risky or not. You should consider it risky or not. A spiral may continue indefinitely. Developers must be assigned during non-development, developers must be reassigned during non-development phase activities. So whenever you are, reassessing the risk, then developers might not be, might be busy in some other work. So their current job might be suspended. So you need to reassign the work to carry out the work again. Obviously, they would be suspended. May be hard to define objective, verifiable milestones that indicate the readiness to be produced throughout the next iteration. So obviously, at every point, whenever you are, verifying and doing the risk analysis, so objectives and deliverables might not be readily available. Yeah. So these are the weaknesses in the spiral model. However, we discussed the strengths and their quadrants, their definitions. They look like a spiral. Every stage looks like a face, and including the risk analysis. So incremental model we did the prototyping model, we did the V-shaped, we did the waterfall model along with the definition of the system development life cycle and software development as a general definition. That was about the today's session. In the next session, we will discuss the agile development methodologies, and that would be the in total unit delivery. Yeah. So I end this session now, and see you next week. Yeah.
All
right then. So I will upload this recording on the Moodle, and I would advise you to send me the your assignment work as soon as possible to my email.
Before you go, I need to ask something on the assignment.
Yeah.
On the software development.
Yeah.
Let me open the assignment.
You want to ask on the software development assignment or the database development assignment?
The database development.
Okay.
The database development. Now, on the activity 1. Where he was asked to use the information on to produce a complex relational database based on response to the client brief.
Yeah.
Now, it's asking to normalize the data to third normal form, produce design documentation in response to the client brief, ensuring that this shows design of the tables. So what I'm asking now, I just have to make all the tables, that's all the entities in the scenario.
Yeah.
Make them into tables, and then make the indexes and constraints.
Yeah.
Then write some SQL queries.
Yeah.
Then I also create forms. Like maybe the customer, you want to input the customer information, the form for the user to see. This is the kind of reports when you want to generate information about the customer.
Yeah.
Okay.
So at least you would include these things, yeah, and no matter, if it is in the any software initially, but you chose, some tables initially, and then you realize, that there needs to be in first normal form, and then, you can explain that, okay, I chosen these are the tables, in the first normal form, then in the second normal form, there are no any, duplication, and the next you apply the indexes, then how do you create the index and constants? You give a command like a create table, with this constants, yeah, and yeah, that will fulfill the requirement, yeah.
Okay.
So
All right.
in any way, you send me by following this, idea, and you will be given the feedback.
All right.
Yeah, and try to complete the all 4 activities and send in one go, yeah, so that we should also consider this your submission as a formal, yeah, and should give you a formal feedback, and overall you should try to get the length of the full length of the assignment, yeah.
Okay.
So I wait for your assignment as soon as possible, and see you next week, yeah.
Okay. Thank you.
Okay then. Yeah. Bye. Bye.
Yeah.